Hi there, this is Rohit from CVR Rocket, and today in this video we are going to learn from fluid dynamics, and the topic is emptying a tank. As you can see, we have a tank, or we can say a cylinder like object. So in that, the upper lid area is capital A and the low portion efflux or hole area is small a, and velocities are respectively capital V and small v. And now from equation of continuity, we know that capital A, capital V is equal to a, small v. And now we can write it as like capital A times minus dy by dt. This dy by dt can be represented in these two ways. If we take the replica of this over here as a tank, we can have two misconceptions. These are not reasons actually. First misconception is we can consider it as small element dy and it's a distance y. We can take it as like that. And second one is we can take certain portion, say some x, to be at a distance of y from the top of the tank outlet, we can say. So both are wrong actually. We are just considering like simply v is equal to distance by time. That means speed is equal to distance by time and velocity is going to be displacement by time, and that is nothing but v is equal to dy by dt, that is, or ds by dt, that means rate of change of displacement. Basic definition, this is going to be the correct one actually. So that is that. And now we can simply write that minus portion because it's decrease in rate, because we are facing a decrease in water level. And then we can just place that minus dy by dt in the numerator and transfer root y over there, and it's just some transformation we have done in this step. And now we want to integrate on both sides RHS from t is equal to 0 to t is equal to t, and LH is going to be y is equal to h1 to y is equal to h2, and just we will integrate with that limits, and here this minus get nullified or just balance, because we are changing the limits h1 to up and h2 to come down, and just we are transforming, and we get finally t is equal to this expression actually. You can read it yourself. And now we have three cases and two comparisons, something like that. And first case is to completely empty the tank, that is h1 is equal to h and h2 is equal to ground level. And if we apply that values over this expression, we get t is equal to this expression. And now for first off, we can use h1 is equal to h and h2 is equal to h by 2, we get this expression. And for second off, we get we can simply write as h1 is equal to h by 2 and h2 is equal to 0, and then we get this expression actually. Simply, as you can see, h1 portion we have to write over here and h2 is 0. h1 h by 2, h2 is equal to 0. We can write like this and we can get this expression. And so from these values we can refer that t2 is greater than t1 and t1 by 2 t2 is equal to root 2 minus 1 actually. That is nothing but 0.414. So this is a quickly video, very interesting video. So again, this is a educational bytes. Signing off and hope to see you more times.